With the power to destroy entire cities in seconds, nuclear weapons changed history forever. But how do they actually work, and why do they still exist? Let's break it down. Welcome back to Understanding the World. Today, we're diving deep into the science behind nuclear weapons, their dramatic history, and the global impact they continue to have on all of us. This is a story of immense power, scientific breakthroughs, and the constant struggle to maintain peace in a world that could end in a flash. So how do these weapons work? It all comes down to two processes: fission and fusion. Fission bombs, the kind used in World War II, work by splitting heavy atoms like uranium or plutonium. When a neutron hits the nucleus of one of these atoms, it splits, releasing a massive amount of energy and more neutrons. This sets off a chain reaction, creating a devastating explosion. Fusion bombs, also known as hydrogen bombs or thermonuclear weapons, are even more powerful. They work by forcing light atoms, like isotopes of hydrogen, to fuse together under extreme heat and pressure. This process, similar to what happens inside the sun, releases thousands of times more energy than a fission bomb. In both cases, the incredible power comes from Albert Einstein's famous equation, E equals mc squared, which shows that a tiny amount of mass can be converted into an enormous amount of energy. The story of the first nuclear weapons began during World War II with a top-secret American program called the Manhattan Project. Fearing that Nazi Germany might develop an atomic bomb first, the United States gathered some of the world's most brilliant scientists to race against time. The project culminated in July 1945 with the first successful test of a nuclear device. Just weeks later, in August 1945, two fission bombs were dropped on the Japanese cities of Hiroshima and Nagasaki, killing over 200,000 people and effectively ending the war. This marked the terrifying dawn of the nuclear age. After World War II, the world didn't find peace. Instead, the United States and the Soviet Union entered a tense period known as the Cold War, defined by a terrifying nuclear arms race. Both superpowers raced to build bigger and more destructive arsenals. They developed hydrogen bombs, intercontinental ballistic missiles, or ICBMs, that could cross oceans in minutes, and submarine-launched missiles that could strike from anywhere. This created a chilling new reality called mutually assured destruction, or MAD. The idea was that if one side launched a nuclear attack, the other would retaliate with equal force, ensuring the destruction of both. For decades, civilization lived under the constant threat that a single mistake or miscalculation could trigger a global catastrophe. Today, the world is a different place, but the nuclear threat has not disappeared. 9 countries are now known to possess nuclear weapons: the United States, Russia, China, the United Kingdom, France, India, Pakistan, Israel, and North Korea, despite international agreements like the Non-Proliferation Treaty, which aims to prevent the spread of these weapons and promote disarmament. Thousands of nuclear warheads still exist, many on high alert. The danger isn't just the initial blast. A nuclear explosion releases deadly fallout and radiation, causing severe illness and long-term environmental damage. Even a small, regional nuclear conflict could have catastrophic global consequences. So, can a nuclear war be prevented? It's the question that has haunted world leaders and citizens for generations. International diplomacy, arms control agreements, and sophisticated early warning systems are all crucial tools that have helped reduce the risk, but they don't eliminate it entirely. Scientists have warned about a scenario called nuclear winter, where even a limited nuclear exchange could throw enough smoke and soot into the atmosphere to block sunlight, drastically cooling the planet and collapsing global agriculture, leading to widespread famine. The only real guarantee of safety is the complete elimination of these weapons, a goal that remains incredibly challenging. From their origins in a secret wartime laboratory to their role in shaping global politics, nuclear weapons have left an undeniable mark on our world. Their existence forces us to confront the best and worst of human ingenuity and the profound responsibility we have to ensure a safe future. What do you think? Should nuclear weapons exist at all? Let us know in the comments. If you found this video informative, please give it a like and subscribe to Understanding the World for more explorations of the topics that shape our world. Thanks for watching, and we'll see you next time.